I am ready. All right, let's work on some problems from quiz 4. And the first problem says classify the curves as a simple, closed, or none of this. Well, I'll draw the curve here. So the curve looks like something like this, and we want to classify this curve as a simple curve or a closed curve or none of this. A closed curve means, let's say we start from here, we go around and we end at the same point. If the start and end point of any curve is the same, we call it closed. If we look at this particular given curve, for this particular given curve, we started from here and end is here, or you may say this is the start and then end. The start point and the end point, they are different, so it is not a closed curve. It's not closed. So this is not a closed, not closed. Okay. Now, simple. Another word, another vocabulary attached to this question is a simple. If we have a curve something like this, let's say this is a closed curve, however, it is intersecting with itself. If we have a curve where we see some kind of intersection of the curve with itself, seeing the intersection, this means not simple. By simple, we simply mean a curve of this type. Well, this was simple, so not intersecting with itself. This will be an example of simple also. If I have a curve like this, it's an open because it's not closed, but it does not intersect with itself, so this is called simple. Now, if you look at this given curve, this curve does not intersect anywhere with itself, so this is simple. So we should be saying this is a simple, not closed curve. Simple but not closed. Okay, let's look at another example. If R and S are parallel lines, if R and S are parallel lines and the measure of the angle A is 38.5 degree, what is the measure of angle E? So let me draw the picture here associated with this problem. So the picture given to us is this. This is a line. So this is a line. Let's say this line is R. This line is R, and there is another line which is S. These two are parallel lines, and there is a transversal going like this, and measure of angle A is given here. This is angle A. Well, this is given like this: A, B, this is C, D, E, F, G and H, and this angle is given to be equal to 38.5 degrees. So that is the information given to us in this question. And what is the measure of angle E? We want to know how much is this angle E here. A is given, this is given, we want to know how much is this. So in order to solve this problem, let us use some of the facts we know from geometry in general and especially for geometry of parallel lines. One of the thing we know is if this angle is 38.5 degree, the angle C being supplementary to this, because sum of this and this should be 180 degree because they will make a straight line. So since this is 38.5, I can say angle C is 180 degree minus 38.5. 180 minus 38.5 will be 180 minus 38.5, that will be 141.5. So, this is 141.5. So, now we know this angle C is 141.5 degrees, and from the property of parallel lines, this angle and this angle has to be the same, because C is 141.5 degree, E has to be 141.5 degree as well. So, the measure of angle E is 141.5 degrees. Okay, let us look at one more problem, and this problem says which figures has the most lines of reflection and rotation symmetry. I kind of have to draw figures here. The first figure a little complicated to draw. Let me draw the second one. Second one is simply a parallelogram. This is the second figure, which is a parallelogram, and the third figure given to us looks like a red cross symbol. So, okay, the third figure looks something like that, and the first figure is kind of star shaped, something like this, maybe some star shaped like this. It is a very regular star shaped. Right now when I was drawing it, this corner looks bigger than this corner, but in fact the given picture, all those corners, all those spikes will be the same. Okay, now out of this these three figures, we want to know which has the most line of symmetry. The line of symmetry means if we fold the picture about that line, if we fold the figure around about the line, it should overlap. For example, if you think of the rectangle, this is the rectangle. If you fold it in the middle, it will overlap. So, this is one line of symmetry for rectangle. Similarly, if we fold it like this, it will overlap. This is another line of symmetry. So, there are two lines of symmetry. However, this given quadrilateral is now rectangle, and we might be tempting to fold it about its diagonal. If we fold it about its diagonal, let us try folding it about diagonal, you will realize it will not kind of overlap. It does not overlap even in the rectangle. So, parallelograms, they do not have a line of reflection symmetry, and if you look at this picture, you might say, well, it is symmetric about this line, it is symmetric about this line. So, there looks like there are two symmetries. However, if you go and look at the star, it is symmetric about this line, it is symmetric about this line. If you join any two opposite spikes, there will be symmetry about that line. So, looking at this picture given to us in our question, I see 1, 2, 3, 4, 5, at least 5 lines of symmetry. So, this star has the most line of symmetry. 1 has the most lines of symmetry. Okay. So, we looked at a geometric problem to identify lines of symmetry. If you have any question, any other question or any question on this explanation or any other question in the quiz, let me know and we will discuss. Thank you for watching. Have a good day.